Hello, my name is Noah Fenton, and welcome to my first Physics 223 video assignment. I chose to do problem 2.53 from the book. The book tells us the acceleration of a particular motorcycle is given as a function of time here, 1.5t minus 0.12t squared. We have to find its position and velocity as functions of time, and then calculate the maximum velocity it attains. So, when we begin with the acceleration, we have to acknowledge that the acceleration will be the second derivative of the position, the first derivative being the velocity. So we have to take the antiderivative of the acceleration to find the velocity of the motorcycle. We add 1 to each of the exponents of the components of the equation for the acceleration, and then divide that by the exponents that we found, giving us the velocity, 1.5t squared over 2 minus 0.12t cubed over 3. We add 1 to each of the exponents on the components of that equation, divide it by the new exponents, and we find the position, which as a function of time is 1.5t cubed over 6 minus 0.12t to the fourth over 12. The book tells us that we have to find when it reaches its peak velocity, which will also be when the acceleration reaches 0. So we set the acceleration equal to 0, which looks like this right here. I subtract 1.5t from this each side, and I flip them so that they're positive. I divide each side by t, and then I divide each side by 0.12, giving me t equals 12.5. Now, we have the time when the motorcycle is at its maximum velocity, but we must find the velocity at that time. To do this, we plug 12.5 into our velocity equation, which gives us 39.1 meters per second, which is the fastest that the motorcycle moves. So, on this problem, we learn that the acceleration of the motorcycle is the second derivative. We must take the antiderivative of that to find the velocity, and the antiderivative of that to find the position. And we learn that they work together, and that you can use values from one equation to find a value in another equation. Basically, everything is connected when you're taking derivatives and antiderivatives of equations, and it's very important to understand the way that those functions work together. Thank you. Have a nice day.